Hello and good day, everyone. Welcome and thank you for joining me in today's webinar. Our topic for today is about design of connections for temporary structures, which is focused mainly on earth retaining structures. My name is Gene. I'm a product engineer for IDEA StatiCa, and I am your presenter for today. So I think most of you knows the drill, but for those new to the webinar, we are using this GoToWebinar platform, and you are recorded. This webinar is actually recorded, and you are muted by default. And as we have a limited time for Q&A, I would really encourage everyone to ask questions while I'm doing the demonstration. My colleague will be answering questions in the background, just like previous. So please type your questions in the applications. And as usual, we will answer questions through email if in case we are not able to answer the questions during the webinar itself. No? So today's topic, let me just turn off my camera in this case. I'm going to share a few use cases in temporary structures, and then I will briefly discuss some of the risks when designing it. And then I also demonstrate how to design the connections for inclined strutting system for the excavation. Then later on, I will demonstrate how to design the reinforcement and anchoring for its truss block. Actually, before deciding this topic, we have actually received multiple queries from our end users who are also attendees from previous webinars, asking whether IDEA StatiCa could cover connections for earth retaining structures. And there are also some users that ask for tutorials on how to model a complex shaped concrete block in detail 3D. So instead of just doing the rectangular or square block. So I think the demo that I prepared for today should basically cover those queries. So before to get started, let's have a quick poll first. I would like to ask you, how open do you design temporary structures? Any temporary structures such as piers, ERSS, bridge shoring, temporary frames, any temporary structures that you can think of, you can try to select your answer. So I will launch the poll. And I let you select which one would you suits your. Okay, so I have a few answers right now. So I'll give you a few seconds so that all of you could select. Okay, I think everyone has already voted. Okay, so 90%. Right. So now I'm going to close the poll. And I will show the poll. Share. All right, so most of you says that very frequent, it's part of my regular task. That's good to know. No, 32% of you says this. And also 30% says occasionally, less than 5 times a year. So this is good to know that most of you do temporary structure as well. And 70% says you are curious about this webinar. So that's fair enough. I would take that as a nice data for me. So let me just stop, hide the polls. And I will continue with my presentation. Let me show it again. Screen. And I'm going to share my poll. Right? Can you see now? I think you can now see my screen. Yeah? So now I want to show a few sample use case in temporary structures. So some of you might already be familiar in it, and I think you guys have done quite a lot of things already, I guess. So let me just share a few things. So in this example, this is actually a framework of a concreting of hammerhead beam. Sometimes we can't just build in a traditional way using props. Otherwise, it would have some obstructions, like, for example, the traffic flows. So in this example, the frame girders actually is supported by console brackets itself. No? And the good thing is that in IDEA StatiCa, you can confidently design the console brackets that is anchored to the concrete pier or the columns. So this is, you can actually design this with confidence using IDEA StatiCa. The same thing with some temporary proprietary formwork manufacturers. No, so they are also commonly using these console brackets. So from here, they can also code checks or check their own console brackets should they want to, and verify it using IDEA StatiCa connection application. So how about lifting frames or lifting beams? I'm sure you guys have doing, especially those engineers that is doing high-rise projects like residential condominiums or HDB blocks, concreting or precast. The use of precast actually is very common. So lifting beams are always a thing, and you have to design it correctly. So here, for your awareness, IDEA StatiCa not just only can be used, you can use for connection, but in member application, you can check the stability of the frame itself, now whether it will buckle during lifting. So this is a good example, this photo right here, of how IDEA StatiCa can code check a lifting frame or a lifting lugs. So another example right here is that, what about tunnel framework, for concreting of tunnels? So for concreting of tunnels, very common that there are quite a number of connections itself, but due to some complexity sometimes of the shape of the tunnels, adapters are very commonly used when you try to do the connections. This is because you need to adapt to the shape of the concrete or the mold itself. And in IDEA StatiCa, when you design adapters, it is pretty much easy when you use connection application in it. So here, in this example, you can see that the number of or C sections that is being designed together with the adapter itself. So another example of temporary structure is a strutting system for deep excavation. Here, as I mentioned, you can use member application as well to check the stability of the frames. And at the same time, this is actually for single strutting, but we have some examples also for laced strutting system. So for laced strutting system, this is very common for a very deep excavation, wherein you really need to check whether your struts are safe or stable enough. So in member application, you can design this with ease and confidence as well, because it will automatically captures the behavior of your strutting system, especially if you want to check for the stability. It's like buckling. So another example of a lace strutting system is this one. It's also similar to lace strutting, but if it's too wide to have an end-to-end strutting, so you really need to anchor it to the ground or to the base. So in this case, you need to check also as well how you can anchor it to the bottom. So in IDEA StatiCa, you can actually model the truss block where where the strut is going to be supported. and you can project this with ease, actually, when you try to apply all the reinforcement into it. So that's basically some of the examples. And I know there are plenty of temporary structures that you can think of. These are just a few of those temporary structures. No, let me, just before that, I will show you about some failures in temporary structure. But in order for us to understand that, we need to know what are the specific loads that are applied to, say, for example, strutting system, because this is what our main focus for today. No? So you have there the loads for example, the geotechnical loadings. You have your soil, water, and surcharge. And you also have thermal loads due to changes in temperature. Obviously, you have some impact loads. You have, for example, you have 50 kilonewtons that you need to apply, and some eccentricity, especially if you have some, I think this is part, most of it is you need to consider eccentricity and also for imperfections. So you have moment as well induced based on that eccentricity also. And of course, the self-weight of the structure itself. So this, all these loads can contribute to failures to our connections, basically. So what are the types of failure that usually can occur in this one? So for example, here, specifically for strutting system, when you have, when you do the design, it is very common that we design using global analysis, global FEA model. And in global FEA model, we only oftentimes check for the member. Well, if the member is okay, this is good enough already. But in sometimes we forget to consider the local failure. For example, here the buckling, crushing, or the crippling of the webs. And another also is that when it is the load is too huge, or you didn't consider for some restraints, then the webs basically you will the flange of the will try to fray sideways, no? Or the rotation of flange related to the web will become option right here. So another thing is that if the strutting fails, basically what you can see in this photo right here, you can clearly see that the column buckles, and also the web members of this laced strutting system actually is also buckling. So if you have to check this with member, you will not have some issues. You can clearly have idea which members is actually failing. And if you don't actually consider some of these failures itself, then there will be some potential or possible collapse that would possibly happens in the construction site. Not only that it can cause the risk of lives, but it's also a waste of resources, and obviously it will delay your project as well. So in this photo right here, you can see it's just when the temporary structure fails, it's actually affected the opposite building. So in this case, the building is pretty much unusable. So that's all that will cost us if we don't consider our design in our design, this guy. So now I'm going to go with my demonstration. So my demonstration, as I mentioned, is specific for excavation or the retaining walls, earth retaining structures. No, but before I do that, let me just one more quick poll. I want to ask you guys, and I will launch this. What tools do you use when designing connections? No? So please try to select the best answer that suits you. And before I close the poll, I will share the the results as well. Now see some progress. Now let me close the poll. Everyone has voted, and I will share the poll as well. Okay, so 44% of you says you use Excel. Okay, that's fair enough. And 30% says you use IDEA StatiCa. But the Excel sheets can probably enhance your, if you use IDEA StatiCa in this case, it would be much easier in that case, no? 20% says other programs. All right, I can deal with that. So let me just hide the polls now. And let me go to my demonstration. Share my screen again. All right, so in this demonstration, this is actually our example. The geometry of this is the depth of the excavation is actually 4 meters, and we have a strut spacing of about 5 meters. So my objective here is actually to design the connections itself, and as well as we are going to design the truss block where the strut is placed or positioned. So before that, I want to know. I want you to tell you that this is easy to do with checkbot application, and the way I'm going to do this is actually using checkbot application as well from my global analysis model. But I'm not discussing checkbot mainly here because we have covered that already in multiple topics in our webinar. And I'm pretty sure all of you guys already know how to use checkbot and how to transfer your global FEA model. So this case, I will just end my presentation and go directly into the model itself. So let me just go through. Let me share my. So here we have this is our model, and we have managed to put in all the nodes in here. So, and this is being transferred into checkbot. And once it's transferred to checkbot, this is basically how it looks like. Now, for me, I will now proceed directly by checking the connections. I will prefer to check the skewed connections right here. This is much easier, I would say, for you all guys, because you're just familiar, but I want to specifically says what will happen if there are some failures I want to show if there are some failures in the connection itself if we follow only the global analysis model. So let me just open this one connection right here. Give it a few seconds while it's being open. All right, so while it's opening, I want to show our reference model. So here, this connections actually is bolted. Welded, but I'm going to demonstrate both welded and bolted connections in this case, just to show some failures in the connection itself. So let me close back again and open the connection app. Right, here it is. We have. So here, I'm going to demonstrate first welded connection. So this is pretty easy. I'm sure you guys know how to do this. It can be achieved by one simple function right here, which is a cut operations. So I'm going to cut that strut with this member, and I'm going to extend my members right here so that it's all fully welded in this case. I'm going to make use of complete joint penetrations, CGP weld, And from here, we have our combinations that is already captured in our global FEA. All I have to do is run the analysis in this case, which is exactly what we saw from the photos, from the image, right, in the previous image that I showed. No? So here we can see in the previous image, this is basically the same, and we can see that there are some failures in it, especially in the analysis. It says very large deformations, which exceeds 1 meter, and plates is about 57% utilization. So if I go back to my slides right here, you can see that there's something's happening because of those specific failures over there. No? And you have this buckling as well. So if you just go, if I use the same, and this is for the bolted, if I use the same for the bolted instead of the weld, I can choose probably 2 operations right here rather quickly as well. So here, let me just say use as a stub, and I'm going to change the bolt size to M20. I will change this to, let's say, okay, I want to put 350. This has some more space for the installer, for the bolts, and I will put some, I will change this to CJP, and I will change this to 6mm. That should do the thing. I will change this to profile. And from here, let me move the bolt to 40, bottom to -60. And let's say there are 2 here. Okay, there are 3 over there. All right. So I have that already. Let me change this to -50. Want to have some more space in it. Now I have that specific bolted connection. Now I need to connect the stubs to the main member as well. So the same thing that we did earlier for the welded one, all I have to do is cut. Once I cut it, all I have to do is change bounding box, and I change this to stub 1, and I extend the member, and it should be connected as well. I'm going to change this to CJP, change this double-sided, let's say this is 8, and I'm going to run the analysis. So obviously the same thing that we have now. I will run the analysis, and you should see the failures as well. Might give it a few seconds while it's running. It takes a bit. So the same thing that we have from there, the same failure that is appearing. So it's still the webs, and the flange is actually trying to rotate, or it's buckles. So in order for us to do that, to correct this, basically, if I just want to put some stiffening in it, but in a global FEA, when we design this, member design is already okay. No, so sometimes we just follow what the global analysis models say, that if your member is okay, your design is already okay. But when you check on this connection itself, you can already see failures. So in order for us to correct this, let me just delete this thing. I will still show the same thing, but in this case, I have prepared my templates for that. But of course, I have just added a simple stiffening plate, which should be the right thing to do. Now, what happens if you have the stiffening plates already in place? If I hit on calculate, now you see that the analysis is already correct. So because we already have addressed those web failures that we have encountered before without adding the stiffening plate itself. Now, so here you can see that in IDEA StatiCa we can code check it very fairly quick and faster, and it's also safer. So this is pretty much easier. So I can click on save basically, and I can close this thing. And that's that thing. I can go directly into the strutting, the truss block itself. As I mentioned earlier, I'm not going to discuss about the stability of this member right here, because member is a different topic, and it's 1 hour to cover that would be not enough if we include that one as well. So that would be a separate topic to discuss later on. So now I'm going to create on the truss block. So let me open this member right here. This node right here. So it should, once I open it, it should open the connection application once more. So I have the connections, I have the loads myself. So this is pretty easy. I know you guys will say this is pretty easy because this is a compression member, and the concrete is pretty much easier to design in this case. So so we have the truss block. This is also very easy to design right here. I just say, okay, I want to make use of the base plate applications right there. So I can change this to C3037, the concrete strength. And let me increase the thickness to, say, for example, 30 mm. And I want to change the sizes of this one to, let's say, just 80, so that I have 400. Oops, sorry. This is 80. And then I will make use of cast in place anchor with the washer, of course. This should be M24, and this should be rectangular. I will change the embedment depth to 300. And since the truss block is rather small, I will have to simulate the size of the truss block as well. To in this case, I'll just have to offset 25 mm, like that. Now we have that pretty much the loads that we have. I can now basically check this if it's okay or not. So I can just hit calculate. So it's pretty straightforward check basically. So we have some welds detailing. So I just have to change this. I'm using 275. It's just right. So as you can see, there are some failures in the anchors itself. And I'm sure you guys know that the failures of the anchor in connection up, for the reason that the reinforcement is not considered. So it's a plain concrete. And if we check on check on the analysis itself and go to anchor directly, we can say that you can see here in the preview, can investigate what types of failure that we have. So here, tensile resistance is okay because this is a compression number, that's fine. But if that's the case, why are we failing? So here we have some concrete edge failure in this case. So that's one of the reasons, because we don't have confinement reinforcement, and in connection up, we only the reinforcement is not considered. So how do we deal with this? Obviously, that's where our detailed 3D application comes in. Now I can export this directly to RC check here, but do you know that you can also do that directly in detailed 3D? So since this is rather straightforward thing, let's try this doing in this way right here. So I'm just going to create a using the 3D app, detailed 3D. I'm just going to create a model. I'm going to use the same settings. Let me just show. Okay, now we have it here. So all I have to do is put in the required parameters now. So this is good to, so I'm going to put in our concrete block now. But before to decide what sizes, this is good also that you have the geometry already ready for you to make the block itself or the shape of your concrete. It's good that we also have the dimensions because we just have to key that right in here. So in this case, in this, I just have to make use of the shape of the blocks. So for example, here I will change this to 1.35 based on the size of my block. Change to 1 meter, and the depth is 0.68. Now I try to use this dimensions right here because later on I'm going to create some negative volume, and from the negative volume I would create a cut for us to make that shape that we want to do. So under that, I will create and select model entity, and then here negative volume. Once I click on negative volume, this will be our, I will change the shape to polygon. Once I shape, I can select the surface. So for example, here I want to put that under surface number 2. There are multiple surfaces actually now that you can see it from the model scene right here. And I will have to also change the shape if that's the case now. So here I will create the dimensions of the negative volume that I want to cut later on so that it will reflect into my concrete here. So in this case, I will change this to 0.22 and this one 0.72. As I mentioned, it is good to have this dimension ready when you are trying to create your own specific model. Change this 0.38. Now this is the shape of the negative volume that I want to be cut off for my, I am as a cutting block for my data. So here, obviously you can see that. So I just made some adjustment in that case. So I'm going to rotate this to, let's say, -90. Okay, I have that one ready. And then the position to, let's say, 2, it should be done. And the Y position to 0.3, I want to move that up. And then under rotation, and then Z position, -0.62. So here, if you can see, this is the shape of my negative volume right there. So from here, I can basically click on operation and click on cut. You can see it's already cut now. And the same thing, I will just make a copy, or instead of making a copy, I can also click on model entity and do negative volume once more so that I could do the same cut for this shape that we have right there. So if we do that once again, in this case, I will have to change this to rectangular. Now, in that case, I will change the depth to 0.38, 0.60, and I will change the surface. So I will put it under surface number 4. I will remove the rotation. I don't want that rotation. I will have to change this to 0.35. That's the case. And I'm going to remove that position offset. And I can once again do the cut. So it's pretty basic function. Oops, sorry. Good. So I just copy, cut. Once copy, I just have to change negative volume number 2. So you can already clearly see that he's doing it pretty quickly and pretty easy. The application is pretty much user friendly. You guys can follow it once you have the right procedure. So I'm going to do the same thing for the other side. Copy. In this case, just change this to 0.38. I will put it under 0 surface number 1 in this case. But I will have to put some changes here. I would say 0.3 only. And then set position here minus 0.3. Okay. Now I have that. So you can see the concept that I'm just only making cut and cut and cut. I'm gonna click on copy. Change this to volume number 3. Oops, sorry. So you see, now it's getting the shape that we need. So I just copy once more, and I'll just have to change it to surface number 3 right here. And again, I'll just copy this thing as well, and I will have to do the same thing. So as you can see, it's pretty relatively easy to model this, the shape of the concrete block itself. And now that we have that, so obviously we can now put in our strutting system. So here, I'll just have to go to model entity, and I will create a base plate out of it. Now it's very important to assign, to apply the position of your base plate based on the surface that we have. Here in this plate, I have to put it somewhere where the slope is. So I have to disable this related to original surface. Remember, our original surface is actually a rectangular shape. I have to disable it so that the new surface is will appear. So in this case, I want to put it under surface number 7. All I have to do, select surface number 7 in this case. And I pretty have that model right there. So I can change also the size of the base plate according to the analysis we have in the connection app. So here I think I choose 400, and on the other side is 350. So I have 25 mm offset at the edge. Now I can change this as well to 30 mm. I can choose S275 as well if you want to. I can shear force transfer to be anchors. And I can change this directly to the load type to be column. So instead of just the plates, you can specifically add the cross sections that you want to make use of. All I have to do is I click on the plus sign, and I select the required sections that I need. Here, I think I'm using HEB 240, so I'm going to select HEB 240. Oops, sorry. So I have to make some rotation in this case, 90, like that. So I have exactly what so basically you have now modeled this case. So I'm going to add some anchors. Do mode entity, single anchor. I'm going to choose cast in place, and I'm going to choose the reinforcement that I want, which is 24 mm diameter, and I have a washer in this case. Of course, we need to use the same geometry that we have, and I know the dimensions exactly. So all I have to do is key that in. So here, I'll have to do 0.16 on the top, and I will change one position 0.125. And all I have to do is copy exactly the same thing. Copy, but I just have to change the dimension from negative to positive. Copy again. This one to positive. And copy again. I will change this to negative. So as you can see, it's relatively easy or quickly as well to model this kind of stuff. So now we are ready to add in our reinforcement in this case. So if I add in the reinforcement, I'm going to make use of rebar assembly right here. I'm going to click on rebar assembly. And then again, it's also relatively easy because all your inputs will be based on the surface of your concrete block. So here I'll have to do, in my example right here, I'll just say I want to make use of more edges of selected surface. And from there, I just want to make use of 12 mm for the slab, because this is anchored to the base slab. I'm also going to make use of continuous member, because in this case, this is a whole slab and we only model a partial of it. So this is a continuous thing, and then my reinforcement should be continuous as well. In the beginning, I will have to put that as continuity, and I will change the cover to 40 and number is 7, and I will change it to, for example, here I have 150 spacing. All right. And I can copy the same thing, but in that case, all I have to do is I'm going to change it to the edges. Now I will select edge 3 and 2, which will be something like that. Okay. You can do that stuff. I can also, you can see a little bit of clash over there. Obviously, you can move that if you like. If not, so also fine. So we don't have some clashing. Okay, now I'm going to put the transverse bar. Again, I will choose group of bars. I'm still going to be using 12 mm in this case, but this time I will choose surface number 2 in this case. Surface number 2, but I'm going to select surface on edge only because I want to, oops, it changes. So surface number 2, yep, that's it. And instead of that, I will change back to 50, but then I will make use of number of layers. It should be 2, and I would change the spacing of my bar to here 200 the space, and then I will have to put that at the top. This one should be 210. All right, so my spacing actually is not correct. Let me just put some concrete cover right here, 40, and that should be fine. And I will also have to put in the cover right here. So let's say 52. Now that should be fine. Let me about that. All right, and that should be correct now. No, again, this is continuous bar. I will have to put that anchorage type to be continuous also on edge to edge, both edge, I would say. Now we're ready to put in some reinforcement into our truss block itself. So as you already know the pattern, we are just making use of the edges of the bars right here. So let me just turn off that bar right there. I'm going to create bar again from here. I'm using 12 mm. But in this time, I will make use of surface number. But first that I will more edges. But this time, surface number 10. And surface number 10, we have the edges 3, 2, and 1, 2, and 3 to follow. So all I have to do is change 1, 2, and 3 here. Now we have that stuff already appearing right there. But this is not like that. So I should have to extend this thing. How to do that? I'll just have to put first edge and second edge. Should be same. I will also have to correct the spacing right here. I want to put it 40. I just want to change 4 and then the spacing to 100. And that should correct our modeling. Okay. And this is pretty close cover as well, so I need to change the concrete cover right here. So here I change to 40, 50 at the top and 40 on the underside. So we have 3 sides. So I have established my reinforcement in there. Now I just have to copy this thing. Copy, but I will change the surface to surface number 11 right here so that the other reinforcement can have on the other side as well. So surface number 11, right there. So I would change this to, instead of 4, I just make use of 2. Then this should be edge number 2, 3, 4, or what's this edge right here? Okay, 2, 3, 4, 3, 4, and that's like that. That's what I exactly want to. And I will have to make some adjustment in the surface cover because I want to place it somewhere right in the middle and space with 175. So if I show everything right there, I can turn it on, I can turn it off. And so I need to make some adjustment into my cover as well. So in this case, let me say 30, 34, and 30, and that should do the, so that I don't have some overlaps. Okay, and the same thing, you know the drill. Modeling, I just click on copy, and pretty much easy, let's say. Yeah? So here I'll just change it to 1 piece. Let's see. But my concrete cover is 475. In that case, I want to put it somewhere here, and I need to change this as well. Oops, sorry. This minus 390, and this one is 390. Right. Okay, so I need to adjust the spacing here to 225 so that it would move down. All right, now we have exactly what we need. Okay. Now I need to put some confinement links. Just make use of, let's say 10 or let's say 8 mm reinforcement. I will make use of the surface, the one at the top. In this case, I have surface number 6. I will deactivate this thing, but I will use 1, 2, 3, 4 edges. This is 50. You can see here, you see over there. In this case, I'm going to change some of those concrete covers as well. So let's say 30, 30, 30, and that should be, all right, that's correct. Let's add some variable because of the slanting stuff. All right, now we have that stuff already. All I have to do is put some number of layers here to be 5 pieces, and it should be 75 mm. Now I have exactly what we need of the reinforcement right there. So it still say here that structure can be calculated because you don't have support. Obviously, we need to add some supports. In this example, I will put surface supports, and I will also have to put in some supports for the edges now, because this is a continuous concrete structure. I have to put some boundary condition or boundary restraint into the edges of the concrete. So for the edge, I mean for the bottom of the slab, this is made up of soil. So I'm going to make use of I'm going to deactivate the direction and just use compression only. I will have to leave it as it is, but this time I will have to use a modulus of subgrade. We have different values. So in this example, I just say this subgrade is to be 150, and then surface number 2. I have here, surface support number 2. I will use surface number 1, but again, I will have to disable the full surface. Just oops, sorry. Related to original, so that's only the size of the concrete slab right there. And it says this is a continuous part, so I'll just have to deactivate that thing and leave it as it is. So you have the stiffness of the concrete itself, which is 3.2. It's just reduce. And I just have to copy the same thing for all 3 edges. Now the front, we don't have some support in there. What I have to do is copy. This is support number 4. Copy the same thing. Surface number 3. Right. So obviously we can now run the analysis from here. Now remember, in our design here, this is actually failing the anchors. But see, when you consider the reinforcement, once we had run the analysis, you can see that this is actually passing. Now I already prepared a few the model this after analysis, so you can see it from here. After putting in the reinforcement and actually following the actual shape that we want to do, you can see that our concrete is actually, or the anchorage is actually passing in this case. And if we go to the code checks, let's say for example, and the strength, this is, we can see also the principal stress. If I select this one, you can see that from there, you'll see that all the forces is actually going all the way to the bottom, to the left side, no? Because our force is actually going in a compression way. So, but you can only see it from the outside, but what about the inside? No? If I cut on sections, you have the options actually also to see what is happening inside. No? So I have cut a few samples of the sections right here, and how the stress look like the principal stress looks inside those concrete blocks. So if I go on the other side, you can also see. So you have limited, you have unlimited options where you want to cut now. So as long as you can find the right geometry where you want to cut, you can establish it now. Okay, so for the reinforcement, you can also see that in the reinforcement right here, you will see some reinforcement stresses as well as the anchors. Now for the anchors, obviously we don't have some problems because this is a compression member right there. But you can see the stresses itself if you want to display it. Now if I go to the report, now most of you need to submit calculation report to agents, to checking agencies or to the authorities. Obviously you need to have the report as well ready. So let me go to the report. You can actually select what kind of report you want, either brief, detailed, or if you want to include only the bill of materials, that's also possible. And you have the options to select as well what to put in the required parameters, and you can also add in some data. For example, here under user paragraph, you can also attach some images into your report. No? So I actually have prepared the report for you guys. So I think I have, let me see. Here, I have added into the report already. You can put the structure that includes the sample, put in any photo you want to put in by under this user paragraph. So that should be no problem in your case to put it in. But the good thing is you have all the code checks available in the report, which is pretty much easily understandable to those who want to check your design calculations. No? So all the stresses, the concrete ratio, something, you have all this readily available in the applications as well. So that is basically my presentation, and I hope you guys learn something about it as well, and I hope that you find it also useful. So let me just go back to my slide to give you a little bit of a summary. So actually, to summarize now, failures actually in temporary structures can basically occur when connections are not properly verified. And safe connection design is very much essential in order to prevent structure collapse. No? And all these things can basically avoided, and you can design connections safely and quickly if you try to make use of our program, IDEA StatiCa. So I hope you guys learned something for today. And to finalize on that, I'll just have one more last poll for you guys before we. So let me just select the required, and I will launch the poll. So please help me select your best answer. And I will give a few seconds before I close the poll. And that's a good, okay, this is good results so far. I would give a few more seconds before I close the poll. Okay, so I close the poll now. I think majority of have voted. I'm going to close, and I'm going to share the results. So 68% says that it improves your confidence in design of connections if you use IDEA StatiCa. That's good to know. And say 56% as well says it saves time compared to Excel spreadsheet and hand calculation. It also improves quality report checking and approval. Oh, that's nice to hear. Okay, so thank you for answering the poll. I'm going to close the poll now. I'm going to hide it. So what to do now? You can actually download the latest version of IDEA StatiCa if you want. If you don't have, you can use you can ask for a code request, or a try. You can use IDEA StatiCa as a trial version as well. You just go directly to our webpage and try to download the program to test it yourself. Okay, you can scan the QR code that I have keyed in, and feel free to try it. Yeah. So after the webinar, I would like to thank you very much for your attendance today. And after the webinar, we actually have some short survey. You will get asked for this survey and how we could improve on the webinar. And also there will be recording available in our webpage if you just visit our webpage. Not only in our webpage, you can also see that in our YouTube channel. And of course, there are also lots of documentations, tutorials, and webinars for the past years. If you miss some webinars, you just go there, you can visit, and not only that, you can also go to the support page and ask for some help desk cases. So yeah, thank you very much. Again, that's it, and thank you, and enjoy the rest of the day. Bye bye.